Assalamualaikum and welcome to the numerical integration class for chapter 6. So before we start our class, please set your mind that you are happy. I'm happy all the time because I choose to be happy. So please stay positive. The storm can be rough, but the sunshine always returns. So make sure that you reset your mind. It can be really hard to stay positive, I know that, but sometimes that's the only way to make it true. And conquer your stress and choose to be happy. Okay, so we can do this. Okay, so can we start our class? So I hope that you will be more energetic. Cool, so today we will have our class on the numerical integration. So in this chapter, it is used to find the area or volume below a curve or bounded by several curves in a graph. So for this chapter, there are several numerical methods to approximate integral, which are trapezoidal rules, Simpson's 1/3 rules, Simpson 3/8 rules, and the Gaussian quadrats. However, we will not cover the Gaussian quadrats. So for the first one, on the trapezoidal rules, so if you can refer here, so what we are going to do is to approximate the area under the curve. So we can see here, this is our graph, and we need to approximate area under the curve, y, which is equal to fx. So fx is actually this function. So we need to calculate the area under the curve. So in this curve, if you can see that it is bounded by a value here. So we have starting with A and final value is B. So if we can refer back into this integration, so the integration is written as integration. So this is our final value, which is our B, and this is our start value, which is A. So for the function of x dx, so it's actually approximating area under the curve. So this is our what we are going to have. So in this method, okay, we are directly goes to the formulation. So in these trapezoidal rules, if you refer into this formula, okay, so there will be if we discretize the area under the curve, okay, as previously we have discretized, so means that we have cut, okay, down into several interval. So in this case, in this case, this is our start value at point x naught, and this is our final value here in terms of xn. So xn is actually the final one, x naught is our first point. So here we have declared A is equal to x naught. So if we refer back to the okay, it's okay. So we will write it as something like this. So in our integral here, so this is our final value and this is our start value. So here the value we have these 2 points based on this graph is A is our start, B is our final value. So before that, you need to find the h value. However, it is not put here. We will use a formula. Later on I will explain about that. So for the trapezoidal rules, so you can see that you will use this formulation. So it's actually that from this integral value for the starting and ending for the function of x, so for the area under the curve, we have discretized from this x naught to x1, x2. So we have cut it into several discretized values. So this area under the curve for this range is A1, under this is A2. Why do we need to do this? Because of, if you can see that the curve is different, so we cannot just use S1. So because it have curve in here, so the area is different, not the same. So that's why it was cut into sample of data. So here that we can see the area of A1 will be plus with A2 and the rest. So you can see here, so we have several of these in integral And then however you do not need to think about that, we will use the formula given for the trapezoidal rules. So if you want to know more, then you can explore yourself. So in this case, if you are using trapezoidal rules, the formula is h/2 between f0. F0 is for our first function of our first area here, okay, and then plus with our final value here. If you can see here, this is our fn, last of our fn here, and then plus with 2 multiply with the summation of everything inside this area of curve. So this is the formula for trapezoidal rules. So we will try to do it in our examples afterwards. Okay, next, before that, okay, I will stop this. Okay, for the first example, 6.1, the question: approximate this integral by using trapezoidal rules with n equal to 8. N is our slice of area that we have cut. So how you want to do this? So the first step is for you to find our h. So in previous slide, I forgot to inform you that the way that you win before we can start, we need to find the h value, because in this formula it's stated here that you have to have h/2. So in order to start, so we need to find the h first. So in order to find the h, we will use this formula. H is equal to b minus a divided by n. So if you refer in this question, that you can see that here is actually this is our a and this is our b. Okay, let's check. So this is our a and this is our b. Okay, so take this value. Okay, b is 0, just put it here, and a is minus 2. So if you put a minus 2 inside a, so you will have plus 2, and put n in here, n is equal to 8. So we have from this question, so you will have the step 1 with value of 0.25.